As discussed in the overview portion of this presentation, the purpose of safety assurance is to evaluate the overall effectiveness of the SMS and the safety of the organization through monitoring, data tracking and analysis, and investigations. Safety assurance is the second major component of an SMS. Black's Law Dictionary gives us a definition of assurance as something that gives confidence. Safety assurance gives us confidence in our safety risk controls. In other words, a properly administered safety assurance process provides confidence that the organization is meeting or exceeding its safety objectives by controlling risk. Safety assurance helps us to control the practical drift, which happens as a natural part of any organization, and gives us confidence that risk controls remain effective. How does safety assurance control drift and the effectiveness of risk controls? The outputs of safety assurance activities feed the other components of the SMS. For example, when safety assurance activities help identify hazards, we conduct the safety risk management process. When negative trends in safety performance are identified through audits, we correct them and share that information across the organization. When compliance issues are identified, we review their impact on policies and procedures. Fundamentally, there are three safety assurance functions: collecting and analyzing information to determine that process requirements are continuously being met, assessing the performance and effectiveness of risk controls, and working hand in hand with safety risk management. Analyzing process requirements asks, how are we doing it? Assessing effectiveness asks, is it working as we intended? Safety assurance is often confused with quality assurance. In truth, they both use many of the same principles and practices. Quality assurance focuses on continually controlling product conformity and customer satisfaction, such as meeting production goals. Safety assurance functions ensure that risk controls perform in a way that continue to meet their safety objectives. SMS encourages the integration of both systems for mutual advantage. The first step of safety assurance is to gain a fundamental understanding of the domain of the process, the system. This requires a comprehensive system description, the who, what, when, where, and how of a system that is documented and as it functions day to day. It's important to understand how the system works and what tasks are involved in key processes. For example, during operation, what are the critical activities that must occur in flight operations, maintenance, ground operations, etc.? The system description should include existing risk controls. The operation of the system must be monitored. For example, flight control. Does it routinely operate smoothly? How about during weather events? Multiple maintenance cancellations? How does NOTAM distribution work? And is the system documentation and records up to date? The bottom line is, when we assess the system operation, we need to ask if the situation is acceptable and are the goals and objectives being met for safety. Safety assurance is linked with safety risk management in the requirement to monitor risk controls during operations. Additionally, if through monitoring a systematic problem is identified, SRM should be applied to that process. When risk controls are acceptable, the system is placed into operation and written documentation is in place to describe the system. If risk controls are not acceptable, we need to determine whether to apply corrective action or, if the design is defective, return to the SRM process. We said earlier that safety assurance was designed to monitor risk controls and help with decision-making. Decision-making needs information, and information comes from data. It's important to collect data and do data mining on data sources that will identify safety concerns that the organization can use to make informed decisions. There are 6 types of data sources discussed in the SMS standard. They're very good data sources, each with a multitude of inputs, and they've been around a long time. Each of these data and information sources exists to some degree in every organization. The SMS standard formalizes requirements for each. SMS specifications for these data sources are left at the functional level, that is the what needs to be done level, allowing individual organizations to tailor the how it needs to be done level to the scope and detail appropriate for the size and complexity of the organization. With limited resources to review the information collected, it's wise to consider in advance what are the most effective sources of data to collect. These 6 categories represent some of the top sources for aviation safety data within the industry. What is continuous monitoring and who has responsibility for it? Continuous monitoring is where the controls, developed in SRM, are directly monitored and evaluated for the safety assurance input. It's the link or interface between the two. As for responsibility, the line managers have direct responsibility to monitor daily activities and processes within their area, assure that processes, procedures, and their controls are complied with, and periodically assess the status of risk controls to assure their functioning as designed. Line organizations are the domain of the technical experts in any organization, and they're the most knowledgeable about the technical processes involved. So why does line management continuously monitor operational data? To assess conformity with risk controls when implemented in the operational environment, to measure the effectiveness of the safety risk controls, to assess system performance, and to identify hazards. Here are some ideas for data sources. The bottom line is to first look for business purposes and then identify the information sources that an organization is already collecting to maximize the applicability and benefit available from that data source. For example, a check and balance can be gained by using pay records to determine whether a control was used. How? Well, if there was an MEL item not to dispatch an aircraft without 2 pilots, were 2 pilots paid for the flight? Audits. The word alone strikes fear in most aviation professionals. But consider this. Under a fully functional SMS, audits are opportunities for organizational improvement. The key point to remember is that internal audits are not intended to be a test that's administered by an outside entity to be passed or failed. Internal audits simply take the pulse of the operation. It's the process owners look at what they're doing so they can gather information they can use to improve and keep their processes on track by periodically looking at current and past activities and results. Through internal audits, line managers can get data to use in making decisions and controlling operations in their area of responsibility. With that in mind, let's look at these opportunities for improvement. The primary responsibility for internal audits rests with line managers of operating departments, with those who own those technical processes. This is where hazards are encountered most directly and where deficiencies in processes contribute to risk, where audits provide direct, detailed feedback to the process owner, and where direct supervisory control and resource allocation can mitigate the risk to acceptable levels. What are some of the key design points of good internal audits? First, they're performed by each operational department on themselves. The director and line managers of operational departments have direct responsibility for ensuring processes in their area of responsibility function as designed. Internal audits are part of that responsibility. Audits should be scheduled on a regular basis. Remember that an audit is a snapshot showing what is occurring at a particular point in time. One audit is not enough. The audit tool needs to be used regularly to be useful. The audit obligation extends to subcontractors that may be used to accomplish organizational functions. Audits should determine conformity and performance of safety risk controls and the department's performance in reaching safety objectives. Finally, remember that an audit does not make you safe. It only shows the situation during one particular period in your organization's life. It is the action resulting from the deficiencies identified that help to control risk and ultimately make your organization a safer place to work. We've discussed internal audits, and now we'll discuss internal evaluations. Well, what's the difference? An internal audit is performed by the operational divisions on themselves. Flight operations does an internal audit on flight operations. In an internal evaluation, the divisions receive evaluations from someone outside their division. Internal evaluations are accomplished by company personnel who are functionally independent of the process being evaluated, focus on the technical processes as well as the end product or service, review the results of internal audits for effective solutions, and finally, sample outputs of the SA components. The internal evaluation function also requires auditing and evaluation of the safety management functions, policymaking, safety risk management, safety assurance, and safety promotion. These evaluations allow the management officials responsible for the SMS to inventory the process of the SMS itself. Another safety assurance data source is external audits. External audits of the SMS may be conducted by code share partners, customer or industry organizations, other third parties selected by the operator, or the regulator, the FAA. These audits not only provide a strong interface with the oversight system, but also serve as a secondary assurance system. Organizations may elect to have third-party audits from organizations such as IATA, CASE, or ACSF, or other consultants. There are no SMS requirements for organizations to hire an external auditor. If the company doesn't get audited, then there will be no external audit data. However, if external audit data is available, typically from code shares or the FAA, then that data must be used in the analysis of data process. Safety investigations, part of our reactive strategies, are often conducted to put the event behind us, to assure everyone it's all okay and normal activity can resume. However, under SMS, the best use of the data is to learn about system vulnerabilities, develop better strategies, and prioritize resources for improved system reliability. Consider how ICAO defines investigation: to prevent accidents by gathering and analyzing information, drawing conclusions, including determining causes and, when appropriate, making safety recommendations. If reports show a high risk potential, then there should be a greater depth of investigation than those with low potential. In other words, the scope of the investigation must factor in the complexity of the situation. SMS depends to a certain extent on investigation, analysis of safety issues, and identification of underlying hazards. The safety assurance process requires an organization to collect data on incidents and accidents and then use that data in the analysis of data process. The quality of the investigation effort is very important in order to identify the underlying hazards. Much has been written about safety investigation techniques and strategies. However, the bottom line for SMS is that investigations must clearly identify underlying hazards. The sixth information source for safety assurance is employee reporting. It is an SMS requirement that an organization develop and implement a confidential employee safety reporting system. All employees should have a means to provide feedback to the management of the company. This is not just event reporting. The main objective of any safety data collection and analysis system is to make events, hazards, safety trends, and their contributing factors visible, understandable, and supported by usable data so that effective corrective actions can be taken. The system must provide confidentiality, and employees must be encouraged to use the system. Historically, we find that even those organizations that have an active ASAP often do not encourage employees to raise safety concerns, report hazards, etc. They just look at events. Data from employee reports may identify emerging hazards. Think about this. Who's better to see an initial hazard indication than those actually accomplishing the activities? From the human error perspective, the behavior of individuals or groups involved in incidents or near misses may not differ greatly from that observed from when accidents occur. Generally, the cognitive failures, problems in decision-making, communication breakdowns, distractions, and all the other factors which contribute to the sum total of behavior in an accident will also be present in incidents. The data collected in the safety reporting and feedback system must be included in the analysis of data. There are several ways to kill an employee reporting system. Burn the reporter, burn the data. Burn the reporter means if an employee is penalized for reporting, a rapid death of the reporting system will happen because the program immediately loses its credibility and other employees in turn will not report safety concerns. The burn the data reference means failure to provide feedback to the reporter. The reality is that if nothing is done with the data, employees will lose faith in the process and stop submitting reports, which can cause the slow death of the reporting system. Data analysis results are used for many things. Comparing activities and performance against a criteria or objectives, such as regulations, international standards, and company policies. Comparing activities and performance against industry, international, and company norms. Spotting patterns from multiple data sources, such as employee reports, audits, investigations. And noting trends over time. Now, be cautious using trends. People often misuse the word trends when they mean patterns. If you don't have data points that are comparable, they cannot be used to predict trends. You must have stable, reliable measures at each time sample for a valid trend. System assessment, the fourth step in the safety assurance process. System assessment applies value judgments to the situation, as understood in terms of available information and the decision maker's past experience. This is where questions such as, is the situation or risk acceptable, and are goals and objectives being met, are asked and answered. There are three possible options for the decision makers during system assessment. First, the objectives are being met. No action is taken and the system will be monitored, analyzed, and assessed again sometime in the future. The second option is where deviations to existing controls are discovered. Some of these failures may be due to lack of supervision, lack of resources, lack of training, or poor job aids. In these cases, the controls themselves appear to be okay or maybe in need of minor correction, but the employees, for whatever reason, are not following their procedures and processes. The standard requires a structured, documented process for preventative and corrective action to place controls back on track. The third option is where new hazards are discovered or risk controls have failed. Sometimes everyone is doing everything that is expected, but it just isn't working to control the level of risk. Possibly the conditions have changed so that the original control is no longer appropriate. Or it could be because of changes in contracts, changes to airports, new equipment, changing demographics of the employee hiring pools, or a variety of new conditions. At any rate, we've identified a new and uncontrolled hazard, so we need to return to the SRM process to redesign the system aspects or develop new controls. When the new hazard or failed control is sent back to SRM for redesign, it will be prioritized according to its criticality. During the last safety assurance step, the preventative corrective action step, we take action on the assessment decisions we just made in the previous system assessment step for problem resolution. Preventative and corrective action should be developed in response to deficiencies. They should be timely, provide effective resolution of the deficiency, and should prevent reoccurrence. Remember that these deficiencies do not represent problems with the system design, thus a redesign of the system using SRM is not necessary. These are examples of preventative and corrective actions. We could increase supervision or emphasize procedures, fix shabby equipment, provide more training, change employee schedules or assignments, and address health and wellness issues. This is not an exhaustive list. Remember that management is responsible for corrective actions, and for the most part, the actions should reside with the operational departments cited in deficiency findings. We are now finished with the 5-step decision-making process, and now we'll explore the last two processes in safety assurance: management review and continuous improvement. Management review closes the SMS loop back to policy. It's where management becomes directly and personally involved in the safety management process. Through such reviews, management learns about changes in the operational environment, identified hazards and related risk controls, effectiveness of risk controls, and status of corrective actions. This knowledge by management will frequently be reflected in organizational policy changes. Management reviews should be done periodically as well as during safety assessments. Specifically, management reviews should include the outputs of SRM and safety assurance, lessons learned, and the need for safety changes throughout the organization. While management review closes the SMS loop, continuous improvement ties the knot that combines the elements of SMS into a whole. As stated in the SMS framework, the organization will develop and maintain a process to identify the causes of substandard safety performance, determine the implications of substandard safety performance, and eliminate or mitigate such causes. That's a tall order. Just how should we go about it? The SMS framework provides guidance through the use of safety and quality policies, safety objectives, audit and evaluation results, analysis of data, corrective and preventative actions, and management reviews. That covers just about everything in the SMS operational environment. Here's another way to view the safety assurance processes. Safety assurance is all about analysis, assessment, and making safety decisions based on information an organization collects and evaluates. Continuous monitoring, day-to-day, flight-by-flight, job-by-job. This is supervision. Internal and external audits. The next step is to go out and look, actively conducting audits, evaluations, surveys, and reviews. Employee reporting. Ensure there's a formal and effective means to listen to the front line and gain the benefit of the knowledge and experience of those actually doing the work. Investigation. Although reactive, it's important to learn from errors, mishaps, occurrences, incidents, and accidents. Affirmed relates to analyzing whether expectations, goals, and objectives are being met. Corrective action. If expectations are not being met and the issue is not systemic, corrective actions should be used to get it back on track. This needn't entail the same level of detail that we used in design or redesign. Many times the corrective action needed is very straightforward. If there are systemic issues, or there are changes to the system, or a control failure, the operation should be taken back to the safety risk management process. Finally, internal evaluations are used to evaluate the entire safety assurance process and the SMS to ensure they are functioning as desired.